If you can hear me, hopefully you can. Okay, so our question is, how many milliliters of 0.10 molars of H2SO4 would you use to titrate 10.0 milliliters of 0.20 capital M NaOH? So the first thing we need to do is write our balanced equation. So our equation will be,
Write big too, so if they can't hear us, at least they can see. Okay, so we have sulfuric acid plus sodium hydroxide, which is an acid plus a base. And in this case, you'll make salt plus a water. And your salt is going to be sodium sulfate. Remember that you have to think about how you write the salt, because it's not just, oh, Na and SO4. Remember, SO4 is a 2 minus ion, so you have to have 2, 1 plus sodium, so Na2SO4. Now we need to balance it.
Right. So we have, okay, so what we have is 2H, 2H.
Balance your salt ion parts first, so the
oh yeah,
NA's
that's right.
first.
I have the hardest time doing that. Okay, so the salt would be NaSO4?
Yes.
Okay, so we have one of those, but here we need 2 NAs. So we probably need a 2 in front of the Na.
Yes.
That is a 2. And then we have, next thing we need to balance, we have 1H here, 1H, and
Okay, keep your ions together. So
right.
This is a hydroxide ion,
right.
an OH minus, and you have 2 of them.
Right.
And you have 2 of these hydrogens. So you're going to combine those, well, plus, to get water.
Right. And we would have 2 waters?
2 waters.
Okay, so we need to convert it to 2 right there.
Let's erase my
okay. I always get confused on that part. Okay, so now that we have our balanced equation, we can move on to the next step, which would be, let's see what we did there.
Okay, so now start with the thing you know the most about.
And the thing we know the most about would be our NaOH.
Yes.
Okay, so.
And don't write the capital M, make sure you call it what it really is. A capital M, molarity, is really moles per liter.
Okay.
So 0.20 moles of sodium hydroxide.
Oh yeah.
Usually you write it in the other order.
Okay. Yeah, I wasn't sure.
That's okay. You guys are learning this actually faster than any other class I've had ever, I think.
Okay, so that would be, see, the capital M is moles over liters, so that would be over 1 liter.
Good.
So then we would take...
What else do you know about the sodium hydroxide?
The sodium hydroxide, we would have to titrate 10.0 milliliters. So we need to convert 10.0 milliliters to liters, and that's really easy. Just take the decimal point, and I'll just do it right here. And move it over 3. 1, 2, 3. So we have. So now we have. Yeah. Times 0.0100 liters, and then just put a little 0 there. Over 1. So now we've converted the Now we've converted the milliliters of NaOH to liters of NaOH.
And you can cancel your liters.
Yes, and you can cancel your liters.
Good.
Okay, so now we need to convert the moles of NaOH to moles of H2SO4.
Okay.
So in the balanced equation, there are 2 moles of NaOH to 1 mole of H2SO4. So we would want to put the 1 mole of H2SO4 on top. Oh, I need to put my moles.
Units are important to us.
Very. On top, and then our 2 moles of NaOH, so they cancel each other out.
Good.
So now we've converted to the moles of H2SO4.
Right. So
Now,
what's your goal? Stop and think. What's your goal?
okay, our goal is to see how many milliliters of moles over liters of H2SO4 would we use to titrate the 10.0 milliliters of 0.20
Right.
moles.
So your answer is going to be milliliters of
Right.
volume. And you have moles right now. And there's no obvious way to convert moles to volume, but you have the concentration. So in this case, you can use the 0.10 molar or mole per liter of the acid to cancel out the moles of acid.
Right. So the way we would do that, and this is the really tricky part, we would flip our equation. So it would be 1 liter over 0.10 milliliters.
Molar.
Oh, sorry.
Moles.
Yeah. Think of the answer. Moles of H2SO4. So the moles would cancel out, and we are left with liters.
Okay, let me give them just a... Okay, so what she did, in case you missed it, this is the trick. This is something that trips people up every time. She took this concentration right here. Oh,
I'll use that one. Yeah.
okay, so this really means 0.10 moles per liter of the H2SO4. But you need to cancel moles. So instead of writing it that way, you can flip your concentration, invert that fraction. So you're basically dividing by molarity instead of multiplying by it. And that allows you to cancel the moles. Take the units you have and use them however you need to get what you need. But make sure that you're canceling the right unit with the right unit, right chemical with the right chemical.
Right. So we have liters now, but we want our answer to be in milliliters, which is a really simple conversion that we learned way back in module 1, 2, or 3. Okay, so a milliliter is 1,000.
1,000 milliliters is a liter.
Is a liter. I always get that confused. So it would be 1,000 milliliters over 1 liter. Plug all that into your calculator and you get 1.0 times 10 to the 1.
Which really means 10, but we have to have
10.
two significant figures.
Right, milliliters of H2SO4.
Okay, and what does that actually mean? Well, you're doing a titration. What it actually means is you're going to take 10 milliliters of the base, put it in your beaker or your flask, and then drip acid in until you reach the end point of the titration, and you should use about 10 milliliters of the acid before you get to the end point. And you'll see that in the lab next week. So thanks, Abby. Thanks, Anna. All right, hit stop.